The concept that our universe could be a computer simulation has sparked immense curiosity and debate among scientists, philosophers, and the general public alike. Exploring this fascinating idea takes us on a journey through the realms of technology, artificial intelligence, and the mind-bending possibilities of our existence. To simulate an entire universe, we would undoubtedly require technology far more advanced than what we currently possess. However, the relentless progression of Moore's law provides a glimmer of hope. For the past 50 years, computing power has doubled approximately every 18 months, although it is now gradually slowing due to physical constraints. Yet, assuming we continue to advance in our ability to miniaturize microchips, which seems highly probable, experts predict that artificial intelligence could surpass human intelligence within the next century. Elon Musk, the visionary entrepreneur, reminds us of the rapid evolution of video games. He recalls that when he was a child, the pinnacle of gaming technology was Pong, a simple game with 2 rectangles on a screen. Fast forward 40 years, and modern video game graphics are barely distinguishable from reality. Musk made this observation 6 years ago, and even within that short time frame, video game engines have become even more astonishingly realistic. One needs only to witness the breathtaking visuals of Unreal Engine 5 to comprehend the potential of virtual worlds that rival our own. These advancements prompt us to ponder the future of gaming and simulation. What will games look like in the next 6 years, the next 60, or even the next 6,000? The boundaries between the virtual and the real may blur to a point where our constructed worlds become indistinguishable from the universe we inhabit. Contemplating the notion of simulating an entire universe raises an important question. What kind of computational power would be necessary to achieve such a feat? An estimate suggests that there are approximately 10 to the power of 80 atoms in the universe, an astronomical number by any measure. To store the data required for each particle's position and momentum calculation, we would need an astonishing 10 to the power of 83 bits. However, data storage alone is not sufficient. We must also consider the computational power required to track the behavior of each particle. Assuming 2 floating point operations per second, or 2 flops per particle, we find ourselves dealing with an inconceivable magnitude of computational power, 2 times 10 to the 80 flops. Such numbers defy conventional language, and we must remember that this only accounts for simulating the universe's contents. When we contemplate the complexities of human intelligence, which can process around 100 trillion calculations per second, multiplied by the billions of individuals, the figures become staggering. To power such an unfathomable simulation, we would require access to multiple Dyson spheres, megastructures capable of capturing the entirety of a star's energy, or harness the energy generated by black holes. This colossal energy demand is one reason renowned physicists like Dr. Michio Kaku remain skeptical about simulation theory. Dr. Kaku argues that simulating an entire universe is scientifically impossible, claiming that the only computer capable of such a feat is the universe itself. While Dr. Kaku's viewpoint may initially appear compelling, it overlooks a critical aspect of how simulations function. When we engage in a 3-dimensional video game, the entire game world is not rendered simultaneously. Instead, the game engine focuses on calculating and rendering only what the player can see and interact with in that particular moment. If our existence were indeed a simulation, it would make sense for the creators to adopt a similar selective rendering technique. Remarkably, there is even evidence suggesting that our reality follows precisely this principle, an intricate web of calculations unfolding only when observed, akin to the workings of a sophisticated video game. The question of whether our universe is a computer simulation continues to elicit both excitement and skepticism. It compels us to reflect on the extraordinary possibilities that technology, artificial intelligence, and the mysteries of our existence offer. As our understanding and capabilities evolve, the truth behind our reality may gradually reveal itself, unraveling the enigma of our simulated universe. Until then, we marvel at the wonders of the present and eagerly anticipate the unfolding chapters of this captivating journey.